Let's go over the factor theorem. Factor theorem states that a polynomial p of x has a factor x minus c if and only if p of c is 0. All right, let's see what this means in an example. Number 1 says use the factor theorem to state whether, what are they giving us? X plus 3 is a factor of this p of x. Now, if we want to do that, if I ask you a question like this, is 2 a factor of 22? Well, what do we do? Oh, let me go ahead and zoom down a little bit. Well, then what you do is you divide 22 by 2, and if the remainder comes out to be 0, the quotient is 11, but there's no remainder. We know this is a factor, right? 2 divides 22 evenly. So we can do a polynomial division, we can do a long division or a synthetic division to see if the remainder comes out to be 0. But we're going to use something a little different called factor theorem this time. They did add, specifically evaluate p at the proper value and then determine whether x plus 3 is a factor. So this is how you do it. If you want to see if this linear factor is a factor, or I should just say if this x plus 3 is a factor of this polynomial, go ahead and find p of negative 3. And if you're wondering where did you get negative 3 from, if that's a factor, then 0 is x equals negative 3. So I'm going to evaluate p of negative 3. Okay, I will go ahead and use direct substitution. And guess what we are expecting to get for the remainder? We'll see about that. Okay. I wish I had my scientific calculator with me, but I can just go to my Google Chrome and just go to a scientific calculator, Desmos Scientific. And I will go ahead and type that in here, okay? Oopsies, I am at graphing calculator. Let me go to Desmos Scientific calculator. Okay, I'll bring this down a little bit and I will type in negative 3 times negative 3 to the 4th power minus 5 times negative 3 to the 3rd power plus 2 times negative 3 and lastly plus 2. When I plugged in negative 3, that is what I got. I'm just double checking to see if I plugged in everything right. So, negative 112. I'm going to write that down over here, okay? That is negative 112. So guess what? Since p of negative 3 is not 0, x plus 3 is not a factor of p of x. If that number came out to be 0, then we would have said x plus 3 is a factor of p of x. But this is not 0. This is not 0. So you know what you can do? What we can do is we can actually do the division because we know how to do synthetic division. So I'm going to go ahead and just check this using synthetic division. I'll put my negative 3 in the box and put the coefficients of negative 3, negative 5, 0, 2, and 2. And if you're wondering why I have a 0, notice that we are missing the quadratic term. It was 4th degree, 3rd degree, it was missing the 2nd degree and jump right to the 1st degree. So I put a 0 for that missing quadratic term. Okay, let's go ahead and do the synthetic division to see if we really don't get the remainder of 0. Bring down the -3 and multiply. Add and multiply. Add again and multiply. And I must add 36 plus 2 and get 32. And if I multiply 38, let me get my baby calculator. 38 times 3, that got me -114. So if I combine them, the remainder came out to be -112. Notice that the remainder did not come out to be 0. So that's why, and you notice how these two numbers are exactly the same. That's why we say that x plus 3 is not a factor of p of x. Remainder is not 0. So we used two different methods to came up with the same conclusion that this factor or this x plus 3 they wanted us to check is not a factor of this polynomial p of x. Okay? We can try another one, number 2. They said use the factor theorem to determine if x minus 2 is a factor of p of x. If we want to check this, we can either divide to see if the remainder is 0, or we can do the direct substitution. So if you want to check if x minus 2 is a factor, find p of 2. Plug in 2 into the function, and let's see if this is equal to 0. Okay. I wrote it down. I'm going to now go to my scientific calculator over here and go ahead and type that in. Maybe I can just fix this one up a little bit. Why not, right? Look at that, look at that. It's not that exciting. I wish it was a 0. Can you do me a favor? I think I may have a typo over here. I was going to do that. Do me a favor, change something on the problem for me. Could you make this, you see, 4th power, 3rd power, and I listed x twice. I really meant to put this to be x squared. If you can please change that for me, that will be great. That is a typo that I mean to change every semester, but I always forget about it. Anyways, if you change it, we will get p of 2 equals 0. Okay, I really wanted to give you an example where it actually comes out to be 0. So we can conclude that because p of 2 is 0, x minus 2 is a factor of p of x. Now, if you want to use an alternate method, if you want to use a different method, we can also check by division. I'll put the 2 in the box, and I'll put the coefficients, and I will do my synthetic division. And looks like all the coefficients are, we don't have to put any zeros because it's going down by 4, 3, 2, 1, and constant. So I'm ready to start the synthetic division. If I bring down the 3, multiply and add. Multiply and add. If I multiply -2 times 2 times -5, I get -10. And if I add these two vertically, that gives me 1. And 2 times 1 is 2. And finally, if I add these two, I get a remainder of 0. Hooray! Because the remainder is 0, this is a second method that just confirmed that x minus 2 is a factor of p of x. So I wanted to give you one example that is not a factor, one example that is a factor. So sorry about that one little typo. I would appreciate it if you can add 13x squared instead of just 13x. Okay, so I think that's it for the factor theorem. I will be back to talk about the very last page, writing a polynomial as a product of linear factors in another video.